To illustrate composite functions, let's say we have a function f of x, and that equals x squared, and g of x equals 3x minus 7. Now, if we wanted to know what the function, the composite function f of g of x looks like, then we would have f of g of x is 3x minus 7. So f of g of x is f of 3x minus 7. Now, this function here is relating to this function f of x. So wherever we see an x in f of x, we can replace it with this expression 3x minus 7. That means instead of x over here, we're replacing it with 3x minus 7, and then we square it. So the function f of x is x squared. If we were looking for f of 3, then wherever we saw an x in the function f of x, we'd replace it with a 3. So that would be, f of 3 would be 3 squared, which is 9. Likewise, we're replacing x with the expression 3x minus 7. So wherever we see an x in f of x, we just replace the x with 3x minus 7. And the f of g is now 3x minus 7 all squared. We can now just FOIL this out. So that would be 9x squared minus 21x minus 21x plus 49, which is 9x squared minus 42x plus 49. If we now want the function g of f of x, that would be g of x squared, because f of x equals x squared, which you can see over here. Now we look at the function g, and instead of x, we can look at the function g of x, which is 3x minus 7. What we're doing now is whatever's inside these brackets, we're replacing x with whatever the contents of that brackets or the brackets are. So whenever we see an x in g of x, we replace it with x squared. So we look at the expression 3x minus 7. So it's 3. We replace x with x squared. 3 times x squared minus 7. And then we can just drop the brackets. And that is our composite function, g of x. Then function f of g of x equals f of 5x, because g of x equals 5x. That's the function you were given here. And now look at f of 5x. Wherever we see an x in f of x, we replace it with 5x. So we look at the function f of x, which is x cubed minus 2. Where we see an x, we replace it with 5x. So f of g will be 5x cubed minus 2. That's 125x cubed minus 2. That's the function f of g. Now the function g of f is g of x cubed minus 2. The function f of x is x cubed minus 2. That's given. Now we look at g of x cubed minus 2. We look at the function g. Wherever we see an x, we replace that x with x cubed minus 2. So we look at the function g of x, which is 5x, and where we see an x, we replace it with x cubed minus 2. So it's 5 times x cubed minus 2, and that's 5x cubed minus 10, and that's the function g of f. Now we can clearly see that f of g does not equal g of f. 125x cubed minus 2 does not equal 5x cubed minus 10. And that's the idea behind composite functions. Okay, so to illustrate the inverse of a function, if we have a function f of x equals 2x minus 7, and we want to find the inverse of this function, f of x, okay, f of x is the same as y, so y equals 2x minus 7. And when we look for the inverse function, we're going to proceed as follows and stick to this layout as it is. Do not deviate from it, because the slightest mistake will mean your solution is not correct. And so f to the minus 1 x When we write this down, we're basically telling your examiner, your marker, that you're now looking for the inverse of the function. So as soon as you write this f to the minus 1 x down, we are going to immediately switch x and y around. In other words, x sits where y is and y sits where x is. So we will have x equals 2y minus 7. All we need to do now is solve for y. So we take the minus 7 across, x plus 7 equals 2y, and then we divide both sides by 2, so y equals x plus 7 over 2. And we write it like this: f to the minus 1x equals x plus 7 over 2. Stick to this layout as it is done. Do not deviate from this, because small things matter, and the most seemingly insignificant detail is very significant. So stick to the structure as we've done here. If g of x is 2x squared, then find the inverse function of g to the minus 1. So find the inverse function of g to the minus 1 of x. So again, y equals 2x squared. Y and g of x are the same thing. Now, when we write down g to the minus 1 of x, we are basically saying we are now looking for the inverse of the function. So immediately we switch x and y around. So x sits where y is and y sits where x is. So x equals 2y squared, and now we solve for y. So we divide by 2, x over 2 equals y squared, and to get y to be the subject, we square root both sides, so y equals the square root of x over 2. And we write this like as g to the minus 1 of x equals the square root of x over 2. If h of x equals 3x squared plus 4, then h to the minus 1x is what we're looking for. So h of x is y, so y equals 3x squared plus 4. We're now going to find h to the minus 1. We can find the inverse of h. Immediately we switch x and y around, so x equals 3y squared plus 4, and now we solve for y. So we take the 4 across to the left, x minus 4 equals 3y squared. We then divide by 3, both sides by 3, so x minus 4 over 3 equals y squared, just coming up here. We now square root both sides because we want y, not y squared. So y equals the square root of x minus 4 over 3, and we write it as h to the minus 1 of x equals the square root of x minus 4 over 3.